Welcome, everyone, to the final new topic of our course. Wow, did that feel really good to say? It felt really good for me to say. I'm really looking forward to reviewing the many lovely mathematical ideas that we've learned over the course of the year, but being able to wrap it up today and looking forward to a week of consolidation with you all in person is very much something that I'm quite looking forward to. Now, today's topic, it might be, because you're young, it might be the most exciting topic of the whole course. It involves the craziest looking formulas, but if you just plug and chug, you can do it. And I want to show you briefly where these formulas come from. I know I said I wouldn't show you how to derive the geometric series formulas and the arithmetic series formulas, but there's a little piece of me inside that really kind of hurts. So if I don't make a video about that today, I'll certainly show it to you when we get together in a couple weeks. But I want to show you why we could use some of these formulas here and where that comes from. Okay. Now, yesterday I got a great question from one of you. One of you said, Mr. Jennings, people don't have 10 grand to just invest right now. Maybe you could come up with it, but you might have to damage some of the relationships in your life and sell your car and sell your couch and sell your computer and make some serious sacrifices to get together some serious change so that you can start an investment for yourself. But a lot of you could pick up that extra shift at Blue Mountain or could cut down your spending in some area and come up with $100 without making big personal sacrifices. And this is the way most people will invest, is they will make these small sacrifices on a regular basis to start saving now and make payments monthly or make payments every quarter or make payments once or twice a year, or even off every paycheck, maybe bi-weekly. Okay. And let's take a look at one of these situations. Wang Hao, he finds a great investment opportunity that's giving him 12% interest compounded monthly. That's really, really good. Okay. And another reason I'm doing that is because the numbers are going to work out very simple. Okay. One of the things that I taught you early in the year was when you're dealing with complex stuff, first of all, make the numbers simple when you're learning, and that's going to help you learn. So he quits his vaping and he uses the savings of $100 every month to make a deposit every month for 12 years. So how much interest is he going to earn? Not only how much money will he have at the end, but let's figure out how much interest that's going to give him. Okay, so let's take a look. Let's imagine that this $100 here, and this is the 1.01, so this is 1% growth. And this is the money we'll say he deposits first. This is his first payment. So it is going to be sitting there in the investment, earning interest for how many periods? Well, let's take a look. Okay, so if we switch to a nice blue pen, it's my favorite. Okay, let's take a look here. He is going to be investing this money for 12 years. All right, so, and there's 12 months in a year. So wouldn't you know, 12 times 12 equals 144. Okay, so this money is going to earn this interest 144 times. Okay, and that's the money he invests first. This is like T1. All right, this is the first deposit that he makes. And then the next month, he keeps on not vaping and he stays quit. Good for you, Wang Hao. Not only will your health thank you, your pocketbook is going to thank you. And this money is going to earn interest for 143. Did you know that if you add up the letters in I love you, it adds up to 143? That's very cool, isn't it? 143 is also 11 times 13. But more than that, Mr. Rogers, the famous children's TV personality from the 70s and 80s, 90s, Mr. Rogers, he kept his weight at 143 pounds religiously. Like he would wake up and weigh himself, and if he weighed more than this, he would go swimming for hours to make sure that he would weigh that every day, because I love you. That was very important to him. And so that's this one. And then this is T3, okay? And it's going to earn interest 142 times. And then so on and so on and so on until we get to the last deposit that he makes, which only earns interest for 1 month. Now, what is it that we're looking at here? So this is the 144th term here. Okay. Now, what are we looking at here? This is a geometric sequence. Okay. How do I know? Because if I say take T2 and divide it by T1, let's do that. $100 divided by $100. Well, those are going to cancel, but this one was 1.01 to the 143, and this is 1.01 to the 144. Okay, notice that there's a common ratio here, 1.01, or at least in this case, the reciprocal of 1.01 is the common ratio between all these terms. So we can use the mathematics of geometric series to add these up. And when you analyze the formulas that we're looking at today, you can just forget all this and plug and chug it. But you can also take a look, can I manipulate that geometric series formula, which look like this? The first term, a times 1 minus r to the n, all divided by 1 minus r. Can I take that and make it equal to the present value formulas for annuities? And indeed you can. You'll see that you can do some algebraic manipulations to this to make that happen. I'll leave that for you and for those of you that want to do some investigation on your own. Okay, so when we're looking at, and there's two topics that we have today, future value and present value, and I'll explain the meaning of them in a second. So here, let's skip over that, future value of an annuity. So what is an annuity? These are series of equal payments that are made at regular time intervals. Okay? Now, payments are made at the end of each compounding period, and this is what was called an ordinary simple annuity. Okay, we're not starting with a big upfront payment and then making smaller payments or things like that. For our purposes, you would calculate those separately using the math from yesterday and the math for today. And then when we're talking about future value, these are how much your annuity will be worth in the future, given that you're making regular payments going forward. So this would be answering the question about Wong Hao, and we'll come back to Wong Hao in a minute once we looked at our formulas. So here's the formula for future value of an annuity. All right, and we'll see that there's been some cancellation that's happened and that the interest rate has become the only thing that's on the bottom. Before you'll mention, remember it was 1 minus r, but because r is the ratio and the common ratio of the terms of a geometric sequence, and 1 plus I was how we got r, we have 1 minus 1 plus I there. And then, so it just works out to I. Also, the sign in this has been flipped, so the sign down there can be flipped as well. Okay, we find this I and the N in the same way as we do for compound interest. So N here is, and let's write down some extra definitions, and I'll share this sheet with you, and you can also include this in your notes. I is equal to the interest rate divided by C. And you'll remember C is the number of compounding periods per year. So if you are compounding monthly, like Wong Hao is, we would take his, we would find his I, and I already told you what it was, but it's very easy. It was 12% divided by 12 compounding periods per year, because he's earning interest monthly. So there's 12 of those, and so we divide that, and so I works out to be 1%, or we can write, that's also writable, as it's writtenable as a 0.01. Okay, and that's why we used 1.01 as the R, the growth factor, the common ratio. Okay, but let's not write that because I don't want confusion between this R, which is the interest rate, and that R, which is growth factor. Okay, so that's how you calculate I. You divide R by C, and then to calculate N, N is the number of times your money is earning interest, or the number of terms even in the sequence. So N is equal to C times time, where time is years. number of years. Okay, so this is how we get n, and this is how we get I. And I goes in two places in the formula. Okay, all right, let's keep going. So if we deposit $450 every 3 months, okay, and you might say, well, $450 is hard to come up with. Okay, come up with $150 every month, and the math is going to work out the same. Right? And so because we're compounding quarterly in this case. So someone is depositing this much, and we want to know how much money are they going to have at the end of 10 years. And then what's the total amount of invested and how much is the total interest. All right, so let's add this up. First of all, we're going to write down our formula, and I think I can remember it. We're going to be talking about future value here because we want to know if I deposit this regularly, that's my regular payment, and I'm going to multiply that by 1 plus I to the n minus 1. 1 plus I to the n minus 1. Okay, and then I'm going to divide that all by I. Okay, so I'm going to have my growth factor there. Basically, it's 1 plus the interest earned raised to the power number of increments of time. And I'm going to subtract 1 from that, divide the whole thing by I. That will tell me how much money I'll have in the future. So let's write down our numbers here. And our numbers are going to be, well, here, this is R. That's our regular payment. 10 years. This is time. Notice it doesn't show up in this formula. So time, so we're compounding quarterly. So that tells me C equals 4. And then from T and C, T times C equals 40. So this is N. Okay, that's N. That's an ugly circle. There we go. Okay. Last thing, what about I? We have 3.2% interest per annum. All right, I'm going to get some questions about this. Delta Math doesn't tell you the interest rate per year. Delta Math is telling you the interest rate per compounding period. It will say 1% monthly interest, which is the same thing as 12% interest per year compounded monthly. All right, so just read the Delta Math carefully to know what is the amount of time it takes to earn that interest. So if we're earning 3.2% interest per year, then we need to divide that by 4 to divide that by C, which is 4, to determine how much interest we're earning per compounding period. And that's going to be 0.8%. And another way of writing that down is 0.008. 2 zeros here, because this would be 1%. If that was 1, 0.8% is less than 1. So it's going to be back there. Okay, so that's my I. That's the amount of interest I'm earning per compounding period. Let's put all of this into the formula. So I'm going to change colors. We will use magenta to discuss this very exciting problem. And we're answering number A. What would be the final amount? What will be the future value of this after 10 years? Future value will be equal to R, which is $450 divided by 1 plus I. So that would be 1.008 raised to the power 40 minus 1 and bracket all divided by 0.008. Isn't that nice? Dividing our money by such a tiny number. That's going to make the answer really big. Okay, so let's plug and chug that on a calculator, and I'll show you how to plug and chug this. All right, so we're going to say 450 times bracket 1.008 raised to the power 40. And then you say minus 1. See, that's 1.008 to the power 40. So it evaluates that bedness for me first. And then I say minus 1, please. And then I end the bracket. And it tells me this is what I've got going on inside there. And then I multiply it by 450. And then I divide. See, that's after I multiply by 450. Divide by 0.008. Okay, divide by this number. And then we see we will have this much money. $21,114.87. Okay, let's take that, copy it. Can I paste here? I don't think I can. No. I have to memorize it. 21,114.87. And we put a dollar sign in front of these things, Mr. Jennings. Okay, so that's how much money that this mystery person is going to have in 10 years using the formula for future value. Let's find out how much they actually paid. Okay, and that's pretty easy. We would take $450. That was their regular payment, and we'd multiply it by the number of payments, which is 40. They deposited every 3 months, so every quarter. They do this 4 times a year because there's 4 seasons in a year, and each season is 3 months long. Okay, so they did that 40 times. So let's see how much that is. 45 times 4 would be 9,000. Right? 9,000. All right. What? No, it can't be. 4, 5. Oh no, it's 18,000 times 40. Right? Yeah, 18,000. There we go. 18,000. So they paid 18,000 to do this. Okay. And what did they earn? Well, they earned that. So let's calculate the amount of interest. So I'm going to take 21,114. 21,114.87. Don't forget the pennies. Every penny adds up in annuities. Okay, and then I'm going to subtract 18,000. So they earned a whopping $3,114.87 in interest. Therefore, they earned about $3,114.87 in interest. Now, maybe you are sitting there and you are saying, Mr. Jennings, you promised me that time was money and that because I was young, I could earn exciting amounts of money. And to be honest, I can't get really excited about $3,000 spaced out over 10 years. Well, I mean, $3,000, you can buy a super nice guitar, you can buy a super not so nice car, you can buy lots of neat things, and that would add value to your life. That's one argument. The other argument is this is a decent amount of interest. I mean, it would be an amazing checking account or savings account, but it's not that great of an interest rate on an investment. We'll take a look at Wong Hao in a second and his 12% interest, and you're going to be like, whoa, okay, that was 12 years, and this is 10 years. This is $450 every 3 months. So he's depositing, he or she or they are depositing $150 per month, and Wong Hao was only doing $100. When we take a look at Wong Hao's interest, you're going to be like, whoa. Okay, so how much would you need to pay quarterly at this amount to save 10 grand in 4 years? So now we're getting into a good interest rate, 7.5% per annum per year. So that's really good. Good morning, honey. So let's take a look at this one. So in this case, we know that our future value, our desired future value is 10 grand. Our interest rate, we're again compounded quarterly, so C equals 4, and we have 7.5 per year. So to find out our I, well, that would be equal to 7.5% divided by 4, which is tantalizingly close to 2%, but it's not quite. It's, jeez, I just do it in my head, and then I just make a mistake, and then everybody laughs at me. 1.875. Yeah, okay, there we go. 1.875%, which is also writable. I can also write that as, oh no, that's where the 1 goes. There. This is our interest rate expressed as a decimal per 3 months. Okay, and then we're going to do this for 4 years. So our n is going to be equal to 4 times 4. Yeah, you would be 10. Okay, so that's going to be, last time I checked, 4 times 4 is 16, so n is going to be 16. And we know our future value, and we want to find how much you would need to pay. What you would need to pay quarterly. Okay, so we are looking for what's our regular payment? What do we need to make regularly? Okay, so let's put it into our formula. We have future value is equal to R multiplied by 1 plus I to the n minus 1 over I. Okay, I remembered it this time. Great. See what practice does for you? And then let's plug in our numbers. We know that 10,000 wants to be equal to R, and I see I'm multiplying R by something, and I don't want to do that. So what I can do is just rearrange my formula right here. This will come to the top, and this will all go to the bottom, okay? Because I can basically multiply this by its reciprocal. Okay, so if I multiply this by its reciprocal, all of it will cancel, and then I multiply that on the other side. I prefer you don't, but you could go cuddle your mummy and your brother. There you go. So that would be how I can rearrange this to isolate R before I even start. So let's plug in our values here. Okay, we're going to plug them in around this 10 grand here. So let's plug those values in magenta for some reason. I, we calculated to be this, so 1 plus I would be 1.001, blah, blah, blah. So we put this under here. We're going to multiply by 0.00, 0.01. Oh, yeah. 1875. Okay, that's this number. I'll zoom in. And I'm going to divide by 1.01875 raised to the power 16 minus 1 down there. Okay, and now that will give me R. So let's plug that on the calculator and find out. 0.0187 is our interest rate per quarter. Multiply that by 10 grand equals, this is what's on the top of our fraction, and then we're going to divide that by bracket 1.01875. Don't make any mistakes here, Mr. Jennings. And you didn't. Okay, raised to the power 16 minus 1 and bracket equals. Okay, now let's see if our answer is reasonable. 541.73. All right. So, would you believe me if I told you that if you needed to have 10 grand in 4 years, that if you paid $540 every 3 months, that you would have that in 4 years? Well, you're making 16 payments. 16 payments of that, let's find out how much you invested. So I'm just going to multiply. This is your total payments. Multiply by 16. So you'll be paying in the neighborhood of $8 2/4 thousand dollars, $8,667 total, and so you would have earned about $1,300 in interest over those 4 years. Sounds totally reasonable. So yeah, this is correct. So that's how you do these. Okay, and then that's it for that topic. Now let's go back to Wong Hao and find out how much money he would make. Okay, so let's just go up here and we'll use our formula here. Future value is equal to the regular payment of $100 he makes per month multiplied by 1 plus I, so that's 1.01 raised to the power 144. I'm going to subtract 1 from that, and we're going to divide all this by 0.01. This is how much money Wong Hao will have. Let me show you where our numbers come from. R, that's the regular payment. That's 100. The growth factor here, the amount we're growing by is that. The number of terms is this. We subtract 1, and then we divide by the interest rate. What is that? Let's plug and chug it. We'll clear everything. So 100 times bracket 1.01 raised to the power 144, subtract 1, end bracket, divide by 0.01 equals, he will have $31,900 after 12 years. Okay, now let's write that down. This is equal to 31,900 and how many dollars? And 6 and 16 cents. Okay, still hard to get excited about $31,000. Well, $31,000 actually, and that's now a pretty nice car. That could be a new car, and it's a significant chunk of change that could shift your life into another dimension. Now, 12 years, not a lot of time. $100 a month, it's something, but it's not a lot. Let's see, how much did he pay? So we have $100 times 144 equals, well, that would be $14,400 is what he paid. Okay, he made 144 payments of $100. So how much interest did he earn? There we go. He more than doubled his money by using this investment strategy. Now, it's important to note that not all of his money doubled. Like the first payment that he made, this one, way more than doubled. Okay, the last payment he made only increased by 1%. But when we add it all together and we see how much growth overall was there, he was able to double his money in 12 years, even though he didn't have all of that money yet. That's pretty cool. It's like by committing to this investment strategy, he's going to double his money in more than double his money in 12 years. That's pretty cool. So congratulations to you, Wong Hao, for quitting vaping. And now this number would be really exciting too if he was able to make, say, $1,000 a month payment. Now that's really hard. That's a significant chunk of change, but still achievable. Okay, so maybe he has to quit Netflix and quit coffee and quit a few other things too to free up $1,000, but it's possible to do. Yeah, let's just take a look. What happened to that first bit of money that he put in? So this would be the growth factor of that money. So let's just take a look. I'll just show you what happened to that first payment that he made. Oh, 1.01 raised to the power 144. So that first payment that he made increased in value by 4.2 times. Okay, so that's now $420, that first $100 that he made. Maybe he didn't quit vaping. Maybe he quit another hobby. All right, so this is how you deal with future value. Now let's take a look at present value. Oh no, I'm going to cut the video off here and make a new video. That'll help you if you're, say, oh, I don't know how to find the answer to this type of question. Okay, so any questions that you do have, hit me up in the chat or by email.